Welcome. I think this is the first talks after the opening of JFall. So thank you for giving me your attention today. Today I will be talking a little about evolution in event source systems. In the abstract, I promised there would be something for everyone. But just for me to get a little bit of a feel of what's in the audience, I'd like to ask you just a couple of questions to see what the level of experience of everyone is. So just first off, who here has been working with an event-sourced application for, I don't know, past 2 years maybe? Right, so let me just step out of the light. Yeah, so that's quite a few people. Who is maybe not working on an event-sourced application right now, but considering moving to event sourcing, or maybe writing a new application using event sourcing? So that's also quite a lot of people. And then I think for the people who are working with event sourcing, I'd like to ask who's using Axon Framework? Maybe a better question is who's using anything else? Still a few. Okay. All right, so then, now I understand why we see the other thing. There's a stream of room number 9 started here on the laptop. So it's a nice mix as I see it here. So I guess there's people who have been working with event-sourced applications for some time, maybe running into problems. How do you deal with changes and keep your application moving forward? So that's the basic also that I'll be putting into this talk here. But as I've said, there's going to be something for everyone. So I'd like to start off with a little bit of an introduction of what event sourcing is. There's a fun analogy here that I like to use, and that's the state of the universe. I mean, we all live in it, so we know it exists. I'll leave some questions about whether planets are flat or round. I'll leave that for you. That's not really interesting for me at the moment. But if we look at this giant thing we're all living in, there is some state we could say about it. It's about 7.2 quintillion years old, or minutes old, sorry. It is about 554 billion light years across, at least as far as we can tell. And there's 10 quintillion, I think it was, quintillion stars approximately in this universe of ours. And another fun thing here to know is there's about 190,000 stars born every minute. So if we are modeling something like the universe, this might be just like a little bit of state that you say, okay, the state of the universe right now is the value of these couple of properties. But then you're looking at, if you're going ahead 1 minute in time, you expect some things to change. Age has increased by 1 minute, and it has stretched by 6 additional light years, and somehow the number of stars didn't change. And well, I know why it didn't change, but maybe if you're looking at this, you're going like, why didn't the number of stars change? Well, the number of stars didn't change because there's another thing. There's also approximately 190,000 stars each minute that just die. And this is where I'd like to show why traditional crud storage is not able to capture something like this. If you're just looking at the state, you'll miss something like this because something was added and was removed. And if it's just a counter, you'll never know why. So what just happened here? Well, I kind of explained it already. There we had this state at our first initial point in time, then time passes and something happens, and we have another state, and the problem that then arises is that that other state is actually just gone. We can not access it anymore. We cannot see what the difference is. Maybe if you're doing something like change capturing or diffing, then you can, but then you're still looking at what the changes are. Maybe you won't know why the changes are there. So this is how traditional software systems usually are modeled. You have state, something changes, you update the state, and the new state becomes the truth and the only truth you'll ever know. In event sourcing, that's the thing that changes. We're not just storing the state, we're storing the events that led to the state. And that would mean if we're looking at the universe, you would have something that just describes this entire process from the Big Bang all the way to where we are now. And then you'll see there might be some interesting other aspects that happened along the way, which you would never have known if you were just looking at the current state of the universe. Because maybe some other civilization rose up somewhere on a planet, also burned down their atmosphere and ended up dying horribly, but we'll never know, or at least not until we can maybe find them. And in a traditional CRUD system, you would never find any trace of that. So right now we're at the top, of course, JFall 2021 event, a very specific event in the history of the universe, but it's where we are. So little comparison, if you look at the the differences between traditional state storage using CRUD or event sourcing, then we've got the CRUD, we store just the current state of the system, whereas in event sourcing we store all the events leading up to the actual state. For CRUD things, we have things like a constant read time complexity. Not sure what I meant there, by the way, but sorry about that. I write, and that's of course, you read state and it's just there, you read from the table and it's there. Whereas if you're going through the event stream, of course, that thing gets bigger and bigger and bigger. So if you want to know the current state, you have more and more events to process before you actually know what the actual state is. So there are ways to deal with that. Like snapshotting, that's maybe fun to know if you want to get into this. I'll skip that today because I'd like to talk more about change and not necessarily about keeping this performance. In the traditional system, it's impossible to determine why something changed. Like I said, if you're capturing changes, like maybe when you're storing something in a database and you're also storing the diff with the previous version, then you might still know something changed, and you might even know what changed, but it's really hard to tell why it changed. And that's one of the beautiful things of event sourcing as well, because we're naming the events, we can capture the intent, the reason why something changed. And the same goes for analysis. If you want to, for example, do analysis on the history of something or how something comes to be in multiple steps, then you cannot do that on just a single state, but you can do it on a series of events, and you can see if maybe a certain series of events happens more often than another. Maybe there are patterns in these events. So just to visualize for a second, here's, for example, a shopping cart. In a traditional system, you might see it just like this. A person just ordered one book, one copy of Domain-Driven Design by Eric Evans. But the thing you're missing here is maybe this person was looking at more than one book before he decided to buy it. And so he added a couple of books and then removed a couple of books and was left with just one in his shopping cart. So this is, of course, something where you could see business value. If you see that this person has ordered one of these 3 books, but he has also expressed interest in the other 2 books, then if one of those books maybe goes on sale, you might be able to say, hey, we can email this person and say the book you were looking at is on sale. And then you can, of course, drive sales with that. So that gives you more detail about what led to the eventual sale of purchase of the book. Typically, we are using some. Sorry, let me start over for that one. When we're building like a event-sourced application, there's usually a couple of components in there. I've used a rather simplified architecture here for some of the apps that we've been building previously. But on the left, we have the application like front end where the user is interacting. You're interacting with the server that's eventually posting things on the event stream. And that's before it's posted on the event stream, the command handler can validate whether the state is actually allowed to progress to this intended state. You can also just stop it and prevent anything from happening. Once the event is in the event stream, it becomes the truth and it will never be removed again. The event is then read by some event processor. This could be inside your application, could be outside of your application. It just depends on what you're going to do with it. And generally, by reading those events, you are creating what's called a projection. And this projection, then in another term for that is generally a read model, because generally we're projecting for something that's optimized for reading. So that whenever the client is requesting information, it doesn't have to go through all the events again, but you can just ask the read model. And this is a pattern that's called CQRS, Command Query Responsibility Segregation. And these two things, event sourcing and CQRS, they really go hand in hand. Almost all applications for event sourcing are somewhat forced into this model, and especially with Axon, they're really heavy on how they model things like query handlers, command handlers, and event handlers. Those are their basic three ways of dealing with event sourcing. So a few more terms, and then we'll go to the juicy part. This is not a full list of terms that'll come around when you're looking at event sourcing, but there's some terms that might come up in my story, so it's good to know if you don't know them. The most important being the aggregate. An aggregate is a piece of software which is usually defined as a set of entities which have a shared consistency border. So everything that happens within that aggregate is being consistent with each other. So that means if you're changing something, then within that aggregate root, everything will keep to the domain rules and the consistency rules defined for that particular group of entities. It can be as simple as a user. It can be as complicated as like a country modeling all sorts of cities and things. But generally, this is the part where commands are received and they're validated against the state of the aggregate, and then see if they're they can change the actual state of the event stream and then eventually emit an event. So then the next one is, of course, the event. The event is actually the unit of change. It's built up of a name or a type in Java. It's a timestamp, generally an order in the global index, because sometimes things and timestamps are just not accurate enough. Obviously a payload containing the change or whatever happened, metadata as far as you need it, and the associated aggregate. So when you're loading an aggregate, the framework knows where to put it. And then another one that's important here is the command. That's the one that precedes an event. This is your expression of an intent. You're trying to change something, so you send the command to an aggregate, and then hopefully you'll end up with an event. So there's this big scary thing usually when people are thinking about event sourcing, and that's the event stream. The big problem is that, the good thing is that it maintains all of history, and it's like one large timeline, but for each aggregate you can find these sort of subplots, if you will, describing sort of substream, which is ordered in the entire stream, but contains all the information for just one aggregate. And the hard thing about it is that it's actually just immutable. If you're doing event sourcing, you should never, ever change events that are in your event stream. That's a theory. In practice, we sometimes have to. But as you can probably tell from a lot of movies that are trying to do things with time travel, changing something in an event stream might feel like time travel. You're going back in time, changing something, and then hopefully it ends up well in the future. But it's also really dangerous, so you can really mess things up if you actually change something in the database. So that's why I like to compare it to time travel. Be careful with it. The theory doesn't say you should never do it for no reason. It's actually pretty dangerous. But at least there will be some ways we can actually do changes without breaking anything. So you should never, but what if we have to? So that's where this, the rest of this talk comes in. There's a couple of changes that I've tried to identify from my experience in, I'd say, about 3 projects. 2 larger ones, one at the bank, one at the Dutch National Police. And the third one is kind of my hobby project, which was a crypto trading bot a couple of years ago, which I also wrote in Axon. So there's things you want to change, and most typically you'll run into things like a read model change, which is actually the easiest one, but we'll get to that later. Typically it's like it's a new structure of the model, or you want to derive data or put more metadata in it or something. It's really easy. Then the next one, it's a bit harder. If you want to try and change events without actually changing them in the database, then you'll get to something that the Axon Framework calls upcasters, but they can help you add new data to events, or at least be backwards compatible with events that are already in the event store when you're trying to change them. Renaming fields is of course when we make typos and the business doesn't like it. Filtering events when we're moving things away. Splitting events is very interesting if your application starts to grow. And corrective events is one where you deal with like really bugs that you have to fix, but you want to be able to find when and where you fixed it. And then I have this last topic that's called drastic changes. They're at the end of this presentation. They're the hardest. And one of them is editing events, and the other one is migrating event streams if you're going to write a new version of your application. So let's get into it. The read model. That's the part that's down here. So it doesn't even actually touch the event stream. There's some sort of event processor that's reading from it, and it's building your read model for you. There's a few ways you can do this. There's the straightforward way, which probably everyone that starts out with event sourcing ends up doing a couple of times. It's the delete and start over. You simply throw away the database of your read model, throw away the token of your event processor, and let it start over. And then it'll start at event 0 and run through everything again and update your database. So that's fun if you have like 1,000, maybe 10,000 events. But it starts to be a real pain in the ass once you get to like 10 million events, because it can literally take days. A different way is build and switch, where you basically build a second read model that is your new storage, new way, and you switch over when it's done. And the third is something I call the Corrective Processor, where you want to update your read model while it's still running. So when would we do something like this? Well, we all make bugs. That's still a truth all the time. So if in the creation of your projection you have a bug, maybe you converted a field the wrong way, or maybe just a table has to be shaped differently, then you can do that. Or when you want to calculate some data, or the other one is happening maybe even more often if there's a change in the read API. I mean, if you've made your read model read optimized for your client, but it's apparently not in production, you find out that it's not the best way, then there's no shame in just saying, okay, let's just make the read model fit the client better. It's after all why it's called a read model. So rebuilding a read model is fairly straightforward. You just have to stop the event processor that's currently updating it. Then you delete the entire model, like I said, and then delete the state of the event processor, which is the token. And then you restart the event processor, and then you wait for it, and you wait for it, and hopefully you'll have profit at the end. This is again to illustrate that this process can take really long. I remember having to import like 6.5 million events and they had to be written to a read model that was on a single very slow server, and then the event processor was just doing changes over and over, and the transaction time of that I think it took like 2 or 3 days. So we did this like maybe once or twice, and then we said, okay, we have to do it some other way. So the other way is the build and switch way, where you literally create a new event processor that just builds your new version of your read model. And this can be completely different. That's the nice thing of this one. You don't have to worry about the old one. You can change databases if you want. There's no limits here until what you can do. So you add this second read model, and you start your new event processor, and it will just start building this new read model, which you can do completely parallel to still using the old one. And that's a good thing here, because the old processor is also running, so if any new events come up, that one's going to update the old one, and you're just slowly catching up with the new one. And once you're done, you can just switch from the old to the new. If it's the same API, then probably the front end doesn't even have to notice. And otherwise, maybe you'll also just release your new API accordingly. Or you can even keep them running next to each other and do things like traffic splitting. If you have 2 front ends for this, once they're up to date, then you have 2 read models, and you can check if your new version is doing what you're hoping it does. And the old one can also even be a backup plan. If you keep it online for maybe another week or 2, you can still say, okay, if something comes up in the new read model and it's a failure, then you can just switch back to the old one. So this is just one that it needs a bit more storage, obviously, because you need to maintain 2 read models. But it's a way that's at least not going to create downtime when you're updating something. So when would you use this? Well, if your read model really changes. Oh, and that's it. Well, so the other one is what I call the corrective processor. This is kind of the way in between the previous 2 ones, and we've been using this a lot in when we're, for example, adding new events. Then we would simply have the event processor that's already updating our read model, just keep running. We even update it to support the new events and the new structure, but you always have this kind of period in the past where this event process already passed. So that's why we fixed the original one. That one will keep updating the read model with anything that's new. But we build the second one that targets the same read model and runs parallel to it, but it starts back at 0, and it basically just tries to catch up. And the result of this is that at some point the entire projection will be corrected, and you might even at some point delete the new event processor, because once it's caught up and the original one has done the corrections for all the new events already, you don't need that second one anymore. Generally, this is also one way we would say, for example, if you're adding a new field to your read model, the new processor would look at the field and say, if it's already there, then apparently it has been updated by the other one by a newer event, then I won't touch it anymore. But if it's not there, then I'll update it with the event that I'm processing right now. So that's one of the things when you add data, or when you're fixing like calculation errors. Maybe you had like a precision error in some of your calculations in the read model. You can just leave the one running that's already fixed, and the other one can fix anything in the past. Right. So that was changing the read model. Like I said at the beginning, that's the easy part. If you're running something like this in a microservice setting, then it's also probably true that you might even have multiple read models already. But that's really easy. So now we're going to get a little bit to the harder part of changing the events. And I put the stop sign here just to indicate again, changing the events is something you have to be really careful about. So think about it and make sure you're making the right choices. And the one thing here is that you have to think about it because the events live forever. That means also if you're rushing into a feature and you're just saying, oh, well, just slap together this event and we'll deal with it later, you will have to deal with it forever. So it just generally pays off to have good design of your events. That's something you really want to think about. I mean, you don't want to go back like waterfall and spend 8 years designing your events and then implementing your system. But it pays off to just think about it a little longer than just say, okay, these are the fields I can see now, and let's just implement it. If you already know that maybe 1 or 2 fields are going to be added to it next sprint, might be useful to also add that as well. And one thing here I'd like to say, you should start small. I've seen this morning at the event sourcing talk of Rotterdam, they had this sort of dilemma he was describing about should we do this huge event that captures all state changes once or should we do a lot of small ones? They were also there in like just one command and a lot of small events. And that's also because if you have your small events, then probably what you have to change is also smaller. If you're like emitting enormous events with all the data in it, then chances are you will have to change that event more and more often. So just keep them small. Something we've been doing in our project is create event hierarchies, and they can really help structuring your, both in structuring your events, but also in grouping like similar events, and then maybe at some point when you're adding an event for corrective measures, for example, you can group it in the hierarchy at some level. And if you do it right, then some of the event processors won't even have to know that there's a new event, as long as it fits the hierarchy somewhere. And there's this nice quote from Mr. Lehman that explains why we have to do changes. He says, if a system is useful, it has to be continuously updated and changed, or it will become less and less useful over time. And I think we all know that this is true. If you stop changing something, the world keeps changing, but the software becomes old. So that's why we have to do changes. So a brief intermission here about event hierarchies. I've shown you a little diagram that shows what I mean by this. You could, for example, say, if I have a user aggregate, then I make this interface that's called a user event. That means all events for the user aggregate implement the user event interface. That makes it easier, for example, if you want to have some sort of event processor that just counts things, then you can let it handle the top level interface, and you can go down in levels of detail. And for example, details event, I've split them here from 2 different ones, but I'll show later that you can also use this to add corrective events without even the system maybe knowing that there's a new event. So it's really as simple as just using interfaces. We've also been using some abstract classes in these hierarchies. They tend to just be more restrictive than interfaces, but at some level, like maybe sharing an ID of something, that's something you want to put in an abstract class. But we try to keep as little information in classes in the hierarchy and most of it in interfaces. And then you can do things like this, where you should say, I'm just interested in any user event, not anything specific. This might be something that logs to a system or just writes to a backup system, or maybe just counts events. And you can abstract on which level do I want to handle these events. All right, so changing things. If we're looking at an event stream, then I can't iterate it often enough, we cannot change it in storage, or at least we shouldn't. And they don't really change. And the frameworks for, at least Axon does, and I think other frameworks will have similar concepts for it, we have something that's called an upcaster. So the upcaster is responsible for when an aggregate is loaded. It will also load all of its events. And during loading, the upcaster chain will look at the events and say, oh, well, this is an old revision, so this has to be upcasted. And then the upcasters will change the representation of the event to match the latest representation of an event. And in Java, they work just with the revision annotation. It's really simple. That's all I had for this one. You can use any type of revision system you want for it. If you want to have numbers or just the UUID of the class, that's fine. Usually it helps if you're just keeping your own semantic changes in there. All right. So adding data. Adding data is straightforward. It's also a natural way of an application to grow. At some point, people want to collect more data, or more data is available from the systems around it, and you just want to add this to your events. So you create a new version of your event that has this new field, but then of course you have to change the event that's already in the stream. And you can use this single event upcaster that Axon has specifically for this purpose. And you should always at least provide default values. I mean, you're going to add a field to a class. It does not really make sense if you're going to introduce null pointers here. So just think about what would be a sensible default value for your class or your new value. And you should also be very mindful about the ordering. I mean, upcasters, of course they have an order because it's the order of the changes you apply. And this order has to be configured in the chain as well. If you're messing that up, then hopefully you'll get an exception and you'll know the problem. Worst case scenario, you'll get like changes that are running through each other, and you're looking at why is this so weird. So we had this user class before with just a user ID, and it can be as simple as just adding a name. Where then a upcaster would say, okay, I'll just add that name and give it a default value. And the upcasters, they, like I said, they work before an event is actually given to an aggregate to be handled. So Axon, for example, reads the events from the database, then parses it with either Xstream or JSON, and it will stop the parsing at the intermediate representation. And at that point, you will have the chance to apply your upcasters, change the intermediate representation, and then eventually it will be passed back to your deserialization framework, and it will become your class. So this is what I just explained. Here's an example for with the Xstream where it's in XML. An upcaster here is just adding a field, the name field that I just showed you, and this is just the entire upcaster. And after this, Xstream will then go through deserializing the class and give it to your code. So renaming fields is basically the same. I tend to try and prevent this as much as possible because they feel like silly changes, but sometimes you have to. It's the same way you make a simple upcaster that just changes the field and you're done with it. It's not very exciting, but it's sometimes it's necessary. So the next change we are looking at here is renaming events. These can definitely be significant. The goal of your event stream should also be that the names of events make sense to whoever's working with you from the business domain. And sometimes you want to like introduce maybe more abstractions. For example, here I said, well, we're updating from LDAP, but at some point we're making it external because maybe there's more than just an LDAP server, and we can do that. And it's it's important to keep it in check with with whatever domain action you're specifying. It can also be conditional, so that's a fun thing here. You could even look at the event and say, oh well, this is an event where some sort of condition is true, then this one we'll rename, and we won't rename another one. And that's also a way where you can sometimes just split the behavior of old events over new increased behavior. So there's this, that's the event type upcaster. It's literally just changes the name of the class and then goes back to deserializing. So the next one is one that people tend to oversee, and to be honest, I haven't really had a concrete example to use it, but it's filtering events. When you're reading from the event stream, you can actually just apply a filter, and this is especially useful if you've had maybe systems that accidentally emitted 2 events of the same type, or you've had like a bug in there and you know, okay, everything before a certain date is wrong, so let's just ignore those. Then you can add such a filtering mechanism to the stream. And it doesn't delete them from the database, so you will still have the information in the database, but when loading an aggregate, it will be effectively gone. There's not actually an upcaster for this, but this is, you can add a filter to the stream that Axon uses when loading the aggregate. Yeah, so it's impractical for corrections. This is the reason I wrote this down is if you want to correct something that went wrong, usually you also want to see that you have corrected it. So if you're just filtering things out, then you will not see that something has been corrected, and maybe somewhere in the future someone will ask whether or not that correction has actually been done. So that's why I recommend not doing that. So the next one is splitting. Splitting is a really nice one if your application is growing and maybe even your event is growing. And the way you can use a split is you can literally just take one event and create a stream of new events which are inserted at the point where the original event was read from the stream. So this helps us reduce the scope of one event, and you can split as many as you want. And it's especially useful if the scope of your application grows and your event handlers are maybe like 100 to 200 lines of code, and you want to say, okay, we want to split this, and then it's a good way to split just the events, and then you can also split the event handlers. Of course, there are some challenges there, because when you're splitting it, you have to still make sure that your transaction boundaries are still what you want to have them. But it's a very nice way to make things smaller again. And this one's also one that Axon provides out of the box, and it's called single entry multi-upcaster, which is literally reading one and yielding a stream of new events. Yes, a stream of events. So it could be, for example, here, when you're saying we used to put all the details of a user updated event in one event, but maybe now we want to respond when an email is changed, maybe by sending an email to verify the email, then you could split this one into events and still be backwards compatible with it. So this is one that's not necessarily in any piece of code that Axon provides, but it's something that we've been doing as a sort of practice, and it's called Corrective Events. They indicate this manual correction on a faulty situation in your project, and it can literally be anything. We've had rounding errors we've had to fix like this. Or maybe conversion errors on certain fields. And well, for example, if a bug caused the email address to be null, but the information is still somewhere else, or maybe it's in an Excel sheet and you want to add that, then we would use a specific endpoint with a specific command that adds the corrective event. And here it's also good to mention that this corrective event will then also, of course, be permanently added to your event store and will be maintained. But that's why it's good to have it inside of a hierarchy somewhere. But it will show you why something changed. And a good way to do it is to extend an already existing event that maybe does what you want it to do. So if you already have this user email updated event and you have to correct the user email of a certain set of users, then it makes sense to let that event extend the user email updated event. Make the name recognizable, and usually we also do something in it. I think that's over here. We tended to also put like an issue number in the name of the event so that whenever you're reading the event log for this, you would also be triggered like, oh, this is something special. All other events have no name or number in it, but this one is something special. And then you can find why this event exists. And an important thing here is that if it's a temporary correction or a one-time correction, then also delete the command handling code again if you don't need it anymore. So these are all the event changing changes. And the last part of this is the part that we call the drastic changes. And they are usually needed when you feel like this. When you're looking at your system and you've been debugging and you're going like, oh my God, this is really trouble. We're having problems in our data and it's just messed up now. Then we will have to go to the drastic changes. But this slide is again to iterate. If you get to this point, make sure you've exhausted all other options before you go into these options. So the first one is then, of course, editing events. And we shouldn't be able to do this, but of course, if we're running a database which hosts our events, then we can do this. And it's definitely a last resort. You should always first consider upcasting or filtering. But if that doesn't work, you can do a one-off change of your events. And there's some good reasons for this. This morning, I heard the same reason for GDPR. If with GDPR, you'd preferably not have any personal data enter your event stream, or at least have it encrypted or some way. But maybe your system's already older than GDPR and it's in there. Then it might be necessary to just go back and delete the information from events. It's not pretty, but if you're having to choose between a big fine from whoever's enforcing GDPR or maybe stopping the application and editing some database fields, it's there. And same thing with anything that leaks into your stream that you don't want. But it's really important you do this in the right way. When you're editing something in the database, shut it down. Make it a maintenance window, shut it down, back up the database, because you're going back in time and you're changing something, so you might not be sure whether or not you're killing your parents or something. Make sure you make a backup. Then eventually edit the database, restart the application, and make sure you validate that whatever you were hoping to achieve is actually what you've achieved. If not, go back and try again and create paradox on paradox on paradox. So remember, it's drastic and it's really a last resort. So the other one is a more natural version where if you're working on an application, you might at some point feel like, okay, we've been doing this event sourcing for like 4 years now, and we have this application with all sorts of baggage, and we feel like we want to make a fresh start. But you don't want to get rid of all of your history. Then you can actually just start a migration, and it's kind of like building a new read model, but then the new read model is actually your new write model for your new version of your application. It works pretty much the same thing, same way, and it's if maybe you're splitting off functionality, or you will really have to change structural things to a lot of things in your events, then it comes in handy. You have a chance to consolidate things or split even thing, restructure, and it's practically for building your 2.0 application. It will definitely take time, especially if your application has been running for 5 years maybe, and you have events in the millions, billions, or quintillions. Then you will know that building a new event stream from an old event stream is going to take time. So here again, you could run shadow mode for the old system and then start working on the new system. And once you're happy about the new system, you can slowly start moving over commands to the new system, and then the old system eventually becomes out of date and you can turn it off. It's also, I mean, that's what I meant with baggage. If you've been building upcasters on upcasters and maybe your upcaster chain has grown to 1,500 upcasters, this is a nice way to say, okay, we have to put all of those together and sort of make a fresh model. Then you can migrate from one to the other. Or when splitting applications, or when merging applications. So I think that was pretty much it. What's this? Summary. All right, summary. So we've looked at what we've been doing. Streams are technically immutable of events. But yeah, well, reality changes all the time. So that's why we have to deal with it. And even though event sourcing gurus will probably come at me with like pitches and pitchforks and hey, if I talk to this on a DDD conference. But the reality is things change, and we have to deal with that. So read models were easy. Events were relatively easy with upcasters if you have like small things to do. Corrective events is a very good way to show a mea culpa if you've made a mistake that you want to fix, and be able to show people that you fixed it. And then database editing is definitely a last resort. I think I've iterated over it at least 4 times now, so that's almost as many times as Brian said that you should rate sessions. So I guess it should stick now. And then the event migration path for moving to a new application while using your your old events as a source. I think that's it. How am I for time? Pretty nice, I think. So then there's time for questions. I saw a hand moving up there, so. If the application was stable after editing events? Oh, okay, so how many times have we done this in our projects? Yes, I think we've done like the editing, that was before we were formally in production. That's when we still felt free to go back into the event stream, maybe edit something, maybe delete something. But there was this point in time where we really said, okay, we're going into production with this application now, so we should also be treating it as production, even in our acceptance area, for example. And then we said, okay, that's also going to force us to think about changes in different ways than just editing the database. So whereas before we went to production, we did a lot of changes just editing, but that's because that's the chance where you can fix things before it becomes legacy. But afterwards, we have actually not yet edited anything by hand. We have added corrective events, and I think we have, on application that's about 4 years old now, I think we have 3 upcasters, so that's not a lot. And I think we have maybe 4 or 5 corrective events. And the most important thing that helped us do this flexibly is this event hierarchy, where we could just With interface, you can sometimes just move things around and say, okay, this needs to go in a different part of the application, then we'll just let it extend a different interface. And since interfaces don't necessarily have to be a strict hierarchy, you can also use like a marker interface and say, okay, this thing has to be handled specifically by something else, then just mark it with your marker interface, and then there's an event processor capable of handling those events. So that's why this event hierarchy is really useful to stay flexible and stay out of the dangerous edits.
If you want to add events and use the event stream migration strategy, can you then also use the event stream process to do a rollback if you think, oh, it was not a good idea, let's go back?
So the question is, if you're using the migration strategy, can you use the event processor to roll back if something looks like a bad idea? Well, there again you have this point where if you're migrating, at some point you're going to have to say this new event stream has become final, and then we have to support it the way it is. But until that point, you can still say, okay, our event migration processor screwed up after about 2 million events. Then you can say, okay, just the first 2 million are fine, then just delete everything afterwards, and then we'll set the processor on that point of time and just let it continue from there after we fixed it. But then again, at some point you're going to have to say this new event stream is now the truth, and then you have to treat it like it's immutable. Anyone else? I see one, two, yes, in the back. Okay, so you're saying about temporary events, and if you delete it, how can you still handle the event? I'll have to correct you on that. I said temporary commands. So they're temporaries, they're just for when you need to fix the problem, and you remove those commands and the command handlers to make sure that that doesn't become part of your API, and somebody at some point says, hey, there's this corrective API thing that looks like I can do it. You don't want that. But the event handlers, of course, you have to keep them. But if it extends a class of an event that's already doing what you want to do, then you don't have to add a specific handler for that. Okay, so there was a question a bit closer here. Yes?
Yes, about the corrective events. The image you showed seemed to me that you insert those directly after a golden event, so basically corrective without the
I think that's then just me making a very poor depiction of what I meant. So I'll look for it because it's over here somewhere, correct? Yeah, so here this is what you mean, right? There's something wrong in the red event and we fixed it in the green event. But I didn't mean to imply here that you insert them. So it could also be that maybe there's this red event where you know something went wrong, then a lot of other things happened, and then we do this corrective action which emits an event correcting whatever went wrong here. And you will, the good thing about this is that you will be able to see in the event stream that you corrected it. And this would be like ideal, you had a problem, you fixed it right away, but in reality there's things happening in between and then you fix it, but at least you can see we fixed it. Okay. I don't see any other hands, so I'd say thank you and have a very pleasant JFall.